Okay, 8-1, day 2. We're going to hypothesis test where the difference in population means is not 0. Not compared to 0, not equal to 0, less than 0, greater than 0, like we had for today. Everything was 0 there in the whole. Today it's not going to be 0 on some of them. So we're going to go right into an example because the process is the same. And you'll see where the difference comes in. Okay, this is, see, in 1981, a study of 70 children, they were looking at how much time kids spent in daycare. So they went from 1981, and then they did a recent study, but our recent is probably like 1995. Yeah, so we'll call it recent, but it's not really recent. So they did a sample of 70 kids, 3 years and under. They found that the mean time per week spent in daycare was 11.5 hours. And the standard deviation, 3.8 hours. A more recent study studied 65 kids 3 years and under, found that the mean time spent in daycare was 20 hours, with a standard deviation of 6.7 hours. We're going to test this at 1% level of significance.
Is that hours a day or hours
a week?
Oh.
A week. No, that was a week. Yeah. Yeah, a day would be, that would be bad.
You only have to see your kid 4 hours a day.
You don't even see it.
Okay, the claim being made is that children spend 9 hours per week more in daycare now than in 1981. Okay. So we are always testing the difference between the two. So 2 days ago when we did these, we would set it up with like an equal to or a greater than and then convert it to a difference. I think it'll be just as easy to start writing the claim as a difference right off the bat. So let's take what they're saying and put it in that math sentence. And it doesn't matter which way you subtract. I can do the average now minus the average from 1981, or I can do the 1981 average minus the recent average. It doesn't matter. What's going to be the difference in the outcome? A positive or a negative outcome. So there's 2 ways to do that. I'm going to go now minus 1981. Okay, what are they saying about this difference? How does it compare to the 9? Less than, greater than, equal to, what is it? It says that they spend 9 hours more in daycare now than in 1981. Equal to 9 hours. It's not saying over 9 hours more, it's saying they're spending 9 hours more, so they're saying that this difference is 9. Okay, which makes the claim the whole.
Wait, why is it equal 9 again?
Right here. It says the children spend 9 hours more in daycare now. So when I subtract the two, I get a difference of 9.
Oh, okay.
It's not at least 9 hours more or more than 9 hours more, it's 9. Yeah, because they'll have a little, if it's different, it will say like more than or less than or something. It'll be indicated right in there. Okay, So then the ha will be not equal to 9. Okay, so we go right into what tail test are we going to do? Two tail, this part's the same. Two tail. I had a 0.01 alpha right here, which put 0.05, 0.05. If you inv norm that, negative 2 point something. 2.58 and positive 2.58. So far so good?
Lauren looking at that.
Oh, nice.
It says Lauren is hot.
Oh. Okay, now we're going to convert our sample difference into a z-score. And we're going to use the exact same formula that we had on Monday. The difference in the sample means equals that sample mean difference minus the population difference. This is where it's going to be different from Monday. Now we have a number here that's not 0, but we still just use the same thing. So, I have to match my samples the way I wrote the claim. So the z-score for now minus 81, x bar now minus x bar 81. I need to see it right there. So the now, the average was 20 minus the 11.5 minus, nope, you take the difference in the sample means and you subtract the difference in the population means. What's the difference in my population means? 9. This is from the whole. This is the whole difference that we put in here. Oh. In the whole, it's 9.
So it's not 9, right?
Nope, because we already did the difference. We've got it subtracted right here. We have the outcome. The bottom is the ugly square root, where we have the standard deviation squared and then divided by the sample size. So we got 6.7 squared over 65 plus, there's the plus, 3.8 squared over 70. And then it's be a good calculator user. So what you need to get this, if you want to do it all in one line, you don't have to. You need an extra set of parentheses around this numerator. So it will do this subtraction first because of the inside parentheses. Then it'll do this subtraction before it divides. So you can get the parentheses to make it do things in the right order.
Yeah.
So where is negative 0.528 on this graph? Unshaded. Here's the 0. We're close to the 0. Unshaded, so that is fail to reject the whole. Neat. Okay, I'm only going to do one of those. The other thing that's in each one of these sections is a confidence interval for the difference. Okay, I'm going to show you the formula that we are not going to do by hand. We're not going to write it down. Okay, it would not be difficult. See, there's the difference in the middle, and you have to do this side and this side. And we could do that, but that's ugly. It's the end of the year, okay? And it is built into our calculators.
Yeah, why are we
So we're
why are we
just-
looking at the formula then?
I just want to have a little appreciation factor for the programmers. So it is built in, we're gonna do the program, so each section, besides having hypothesis testing, is going to have a confidence interval for the difference in the population values. So, we're gonna do one of these, and you're gonna be able, I don't want you to crank through it and write down the number, I want you to tell me what this interval means at the end. So, here we go. Number 2 is a confidence interval for the mu1 minus mu2. The difference in the population means. Okay, because it's a confidence interval, what do you think the program is called? It's going to end in int.
Is it 2 stamp Z int?
It is 2 stamp Z int. 2 stamp Z int. Alright, this one was comparing a diet, herbal supplement. Does this herbal supplement help you to lose more weight?
I love probably.
I know. So we've got our herbal supplement. They had 42 subjects. Their average weight loss was 3.2 pounds, and everybody followed a high fiber, low calorie diet besides. And then the standard deviation was 3.3 pounds.
More than the average.
That's more than the average loss, so that tells you some people gained weight on their herbal supplement diet. Okay, yeah. The other group still followed the same high fiber, low calorie diet, but did not get this herbal supplement. They got the placebo, the good old placebo. Okay, they also had 42 participants.
I don't think that because people in medical trials like get this placebo because the drug actually helps them get it. What is it?
4.1 was the average weight loss.
Is that, what is that?
What is what? It's like it's nothing. It's like if this was in pill form, we said the herbal, this having to have like sugar, usually
It
sugar.
would be like a fake pill.
Yeah. So it's still a pill, but it doesn't have.
But they're told that
Yeah.
it is.
And a lot of times it's blind, so you don't know, so you don't get this placebo effect. Hopefully.
I always feel bad for people.
I know. And then you hope it gets through the marketing thing, or the, not the marketing, but the, what do you call that when the government looks at it? Whatever it is.
It's a trial.
Trial. Okay. So we are going to do a 95% confidence interval for, and let's go the average loss for the herbal people minus the average loss for the placebo. Okay, we are not going to do the ugly formula. We're just going to run through the program. So grab a calculator, make sure we understand what goes in each spot.
Would that information have to be given to us too, like this?
The interval, yeah. The percentage,
No,
oh.
like the subtraction, like this mean, minus this mean?
I think it does ask for the, tell you which way it wants it. If not, you just identify it as I did it this way.
Like what does it allow, like what does it tell us?
That's what we're gonna talk about when we get there. Okay, so run through it, plug the numbers in. Again, that's the one part about stats, is it just gets to be a lot of button pushing and okay, what does it all mean? So make sure you grab the one that ends in int.